As always, I hope you enjoyed today's discussion. I'm confident you will, because we've got some great guest speakers with us, which I will introduce momentarily. Just a quick introduction. So for those of you that don't know me, my name is Megan Roney. I am a business development manager for Toromont Power Systems with our Prime Group. And I will be moderating today's discussion. And also helping me moderate is my colleague, John Shaw, who is our product manager for Toromont Power Systems Group. Thanks, John, for joining us. All right, so before we begin, as usual, just a few quick housekeeping items. Towards the end of the webinar today, we do have a scheduled Q&A session, so please feel free to submit any questions that you have throughout the webinar using that Q&A function on your screen. You should see it. And we will do our best to address those questions in the second half of the webinar. And if we're not able to get to them, then we will follow up with you. We'll reach out afterwards separately. I do want to mention that today's session is being recorded as well, and that recording will be made available to all the registered attendees. So now I just have to read a quick disclaimer. We can get started. So this presentation and the information contained herein are provided without a prejudice basis and does not constitute, nor should it be construed to constitute, legal advice or guarantee, offer, representation, or warranty on behalf of Toromont. The panel members will be offering suggestions to several possible customer scenarios, and the answers given by the panel members should be used as a guide. Okay, so without further ado, let's introduce our two guest speakers today. So first off, it is my pleasure to introduce Mary Quintana. Mary is an energy and environment professional with an engineering background, a master's degree in technology management, and a master's of environment and sustainability. And she is currently the director of asset management and utilities at Brock University. She's been with Brock for about 3.5 years, and prior to that, Mary was the energy and carbon manager, as well as the energy and environmental specialist at Western University for a total of about 9 years. Mary, it's such a pleasure to have you with us. Thank you very much for being here.
Thank you for having me, Megan.
Great. And then our second guest speaker who I'd like to introduce is actually a colleague of mine, Sharanjit Singh. And Sharanjit has been with Toromont for a short 27 years. And in that time, he has had numerous roles across the organization, including engineering, operations, sales, product support, and his current role is business development manager and consultant account manager for power systems with a focus on renewable and green energy solutions. So welcome, Sharanjit. Thank you for joining us as well.
Thank you, Megan. Good afternoon, everyone.
Okay, so we're going to start with Mary. Let's just dive right in, Mary. So first question, can you tell us a little bit about your background as well as your current role with the university?
Sure. So I've been out and about. I started by doing research and development, mostly on early detection of cancer using imaging systems. But then it was not what I was happy doing. I've also done some consulting. And then over a decade ago, in 2010, I started working in the higher education sector. And that's really where I found my niche. I really like the idea of a knowledge-based economy and just the environment of a university being the repositories of the leaders of the future and all of these activities, research, operations. It's just very exciting. I've always had a passion for sustainability and technology, so it just suited me very, very well. And I really enjoyed the past few years where sustainability, carbon management, all of those topics that were also so close to my heart now have become trendy, and they have become a topic that everyone is talking about. So it's very, very interesting to be part of this movement now. In my current role, I have a diverse portfolio, which I very much enjoy. My team looks after the district energy system, asset management, so that would be the facility condition index, deferred maintenance, some of the capital planning, but also vehicles and even art. We have under my portfolio some of the flagship buildings. One of them is art, the other one is research-intensive facilities. So it's quite diverse, and I get exposed to a bunch of different topics, but ultimately it all brings together our community. We're a tightly knit community here at Brock, but also it presents how many stakeholders would be facing the same challenges in different manners. So that's something that provides me with perspective and also humility on realizing what others also have to deal with and what their perspective on what we're doing is.
Great. Very interesting. Okay, thanks, Mary. There was probably, not everybody on the call may know that Brock and Toromont have been collaborating for a very long time. I think it was over 25 years ago. We commissioned a 6.4 megawatt district energy plant that's been operating. It's been operating ever since. And Brock University recently completed their district energy efficiency project, referred to as DEEP, which has sort of upgraded and modernized the university's cogeneration facility. Can you tell us a little bit about this project and the impact that it's had on energy efficiency as well as carbon reduction?
Certainly. Well, the system was commissioned, the original system, back in 1994, and it was already a visionary decision by leaders back then because it was a hot water system, not a steam one. So it was already state of the art. It was disruptive for its time. And this time around, we were not less visionary. We continued with the same line. We continued with hot water, but we just took it to the next level because it became one of the leading projects to reduce our carbon emissions. As you may imagine, the plant is the source of most of Brock's carbon emissions, so it just made sense to start there. One of the biggest changes was going from 8 engines to 4 engines. So now we have 4 engines, they are larger. Now we have 7.9 megawatts of generating capacity. And these engines, they also have far more functionality than the old ones. The old ones, they were either on or off. One of the biggest differences we notice with these new engines is that they can modulate. They respond to changes in the load and they automatically load follow. Or we can also set them to generate on a base load basis. That provides us with much flexibility. It prevents us from having to sell to the grid. It's something we didn't want to continue doing. So with the new engines, we were able to get beyond that. So now we don't have that type of agreement with Electra, and it's certainly been very productive for us because we can also better match the campus thermal needs to what the engines are producing. So the ability that we have now to modulate and operate the plant, it's tenfold compared to what we had before, even though the engines are bigger. And at first it was probably one of the biggest hesitations that if we are going to be operating in the same manner, then these are bigger engines. But no, that has not been really an issue. It's one of the advantages that we see. Also, the engines, they work very nicely with what's actually a tri-generation system. We also have an absorption chiller that's fed from the plant. So we're utilizing waste heat from the engines and generating cooling in the form of chilled water for our buildings. This also helps us to run the engines more if we want to, but then at the same time, if we don't have the need for heating, we can still use that heat. It doesn't go to waste. So that also increases our efficiency. All of that has led to significant reductions in our daily consumption of natural gas, and therefore it has also reduced our carbon emissions. We have seen overall reduction before the pandemic of 14%. So it was a significant reduction. And considering that we We did that change in about 1 year. The design started in 2017, and by 2019, all 4 engines were completely functional. And we have continued making more and more improvements over time. We feel that we haven't really exploited everything that we can do. We'll just continue doing more and optimizing our operations, tying them to the new equipment we have. We also have a brand new smart chiller. And all of this was also part of a project, an innovative project that was done with the Government of Ontario via the Greenhouse Gas Retrofit Program for universities and the Strategic Infrastructure Fund from the federal government. So Brock contributed part of that funding. So really the results that we are seeing in terms of carbon reductions, efficiency, and resiliency are beyond our best expectations.
Wow, that's awesome. That's great. So along those same lines, moving away from maybe carbon reduction, but I think everybody who's joining us today probably remembers back in August 2003, there was more than 10 million people in Ontario that were without power. I think it was the largest power outage in North America. And people didn't have power for days, but Brock, I do recall, was sort of they had a success story around the university because they were able to immediately kind of operate in isolation mode, which allowed you guys to completely be self-sufficient from the grid, protect critical facilities and laboratories on campus. So can you talk a little bit about the consideration of resiliency and where that sort of sits on the priority scale for you guys when you're considering projects that also are looking at improving energy efficiency or reducing carbon?
I would say resilience is probably the top priority for us.
Okay.
The fact that our cogeneration plant serves about 85% of the campus needs, it speaks to the importance of having the system operating. We have a community of about 25,000 people. So we are a small town for all intended purposes. And we have about $1.3 billion in assets that have to be protected. And that's not even counting research and all of that knowledge that would be lost if we lose some of the samples or some of the research happening. So for us, resilience is not only the buildings, it's also the people and the knowledge that we are generating here on campus with our faculty and researchers. It's paramount for us. And one of the guiding principles that we have is we always need to make sure that we are running enough engines so that we can isolate from the grid if necessary. So the critical loads that we have on campus, they can be carried at any given time by our cogeneration plant. And if need be, we could also carry the whole campus. That's how important resilience is for us, that in the event of another outage, like the one from 2003, knock on wood, then we can actually protect all of our buildings and keep everyone safe for a duration of time. We also have a non-interruptible system with Enbridge, so we can continue running like that for several hours or days if need be. Again, all to say that resilience is paramount for us.
Okay, interesting. I guess when it sounds like it's a fine balance between reducing carbon, ensuring that if reliability is a top priority, then yeah, it's challenging, I would imagine. And speaking of challenges, what type of challenges does the university face when you're trying to achieve some of these goals, whether it's reducing carbon or just getting a project to cross the finish line or getting the funds for the project? Do you have any advice on how to overcome some of those challenges?
How much time did you say we have? No, just kidding. There's many challenges, and they are not the same for any organization. It can be anything from being landlocked to maybe not being able to use your agricultural land. So it changes from one institution to another. For Brock, one of our challenges is certainly the technology management portion. We need to find a balance so that we don't invest only on one solution. For example, we are not envisioning that we be completely electrifying our systems. There's just not enough infrastructure to completely get rid of natural gas and other fossil fuels by just using electricity alone. So we are thinking of doing solar thermal. We're thinking of looking at geothermal. We are strongly investing and considering conservation, anything from lighting retrofits to the envelope of the new construction. All of those things, they play a part, but we have to balance them all. We have to balance what technologies we bring to have that diversity and the flexibility to operate, and at the same time maintain the flexibility that we want and to be cost effective. So it's certainly quite a balancing act. It's not easy to manage the technology. We don't know what technologies will be available in 20 years. We don't know how fast they will be commercialized, what funding structures there will be for them. So we have to make decisions, mostly backcasting, because we don't know exactly what we're going to be installing. With the same, not only the technology management comes in place, but the change management itself. We are going to be dealing with new technologies. We are going to be having to change our own processes, our own organizational values in some instances. For example, instead of looking at things just in terms of the immediate cost, the capital cost, we need to start thinking about net present value, more about risk mitigation, resilience, all of those things. They have to be considered more into the equation. But it's very difficult to change the mentality because organizations have operated like this for hundreds of years, probably. I would say maybe another challenge for us, and again, that's quite unique maybe for institutions, is the large number of stakeholders that we have. We have not only thousands of people on campus, but also we have different perspectives. As I mentioned before, we have researchers, we have faculty, we have municipalities, and everyone has different needs, different priorities as well, and different perspectives on what they want to see. So we need to make sure that we address those. An example would be, it's maybe a little crass, but air travel. When we can actually resume air travel, instead of going to check on a project in Rwanda or somewhere around the world, then how can we make a better use of our resources so that we don't increase our emissions, scope 3 emissions, for example. So it's all of those things that also require the engagement and participation of our community. And we're already starting to tackle some of that. We're building an energy dashboard. We'll be launching it in the next month, hopefully. But that also speaks to the importance of realizing who are your stakeholders and how you're going to make them part of the solution. And that's, when it comes to stakeholders, we have to see research and other staff members also as partners. We have the constraint of capital. That's not news to anyone in any sector, but also we have the human capital constraints. We have to make sure that we have our teams developing the skills that they need for addressing these new challenges, that we have the mindsets of adapting, of changing, because the world is changing. We have technologies changing and processes. So we need to make sure that our teams are able to change with the times, that we keep them trained and engaged. And that human capital really, it's what would make the difference. And I know our associate vice president always says that we punch above our weight. And I think that's precisely because it's something that Brock really values. It's people and the capital that we are creating, the knowledge that we are creating, and how we work around those challenges together.
Oh, okay, that's great. Thanks, Mary. So Mary, we're going to circle back with you during the Q&A again. So to appreciate those responses, that's really very interesting. So I'm just going to, if I could draw your attention to the next slide here. Thanks, John. So this graph, we actually pulled this data from a recent webinar put on by Smart Energy Decisions, and they were highlighting that the majority of customers, when choosing a supplier, overwhelmingly base their selection on that supplier's capabilities. So as demonstrated in this chart, you can see that the greatest, I think it's the next one, the next slide, John, the greatest challenge for customers is actually understanding capabilities of a given supplier. And especially as the industry is moving rapidly into the renewable energy space, there's lots of new companies, a lot of new technologies. It can be very difficult to navigate for customers. And we're hearing this message from our customers as well. So what we wanted to do was spend some time today just touching briefly on Toromont Power Systems and our capabilities, particularly around our green energy solutions. So I'm going to pass the mic to my colleague Sharanjit, and he's going to touch on some of that, some of the renewable and low emission product offerings that we have. And then following that, we will move into the Q&A session. So Sharanjit.
Thanks, Megan. Slide, please. So Toromont Power Systems is the CAT dealer for Eastern Canada, from Manitoba east all the way to Newfoundland, and from the 49th parallel all the way to the North Pole. And we participate in all aspects of Caterpillar's business. So we participate in standby generator sets, prime power sites, remote, mining, rental, marine, and we have strategically positioned our service branches. Our branch network consists of branches in all different locations in major centers and able to provide power generation services. In addition to that, Toromont Cat Power Systems also has two large engineering and project management groups, one based in Pointe Claire in Quebec and the other one based in Brampton, Ontario. And these teams basically will design and provide project management activities for a project, any project that we are able to provide to our customers. So we provide full service operations. Our branches have service technicians that are dedicated to power systems business, specializing in all different aspects, some specializing in electrical side of the business, some on the mechanical side, and generally work together with customers in order to provide service. So Caterpillar equipment is used as a basis of our design, and Toromont Power Systems basically provides a solution based on the customer's needs and uses the CAT equipment as the basis of design and procures materials and designs, manufactures, validates, and provides installation assistance and commissioning for any projects. John? So the next couple of slides I'm going to talk about is some of the green energy solutions that Toromont and Caterpillar can provide, and how they have impact in forming up a microgrid and providing resiliency and high efficiency solutions. So one of the first ones is solar PV modules. Caterpillar is now able to provide solar PV modules, and these are manufactured for global deployment. And as a result, Caterpillar has quality control standards in place so that these modules are tested and can be used globally in any operations, ranging from a coastal environment to an Arctic environment and to a high ambient temperature environment. These solar panels are robust, superior performance in the sense that are higher than industry standard efficiencies. One of the things with solar PV modules is the rating on this. These panels are rated for -0 plus 5 watts, which means that that's an indication of a high quality solar panels. In addition to that, Toromont, through its strategic partnerships, can provide DC to AC inverters, combiner boxes, different type of rackings, and provide a complete solar system designed and installed for a customer's needs. And these systems are such they can be scaled to any requirements. They're compatible with the Microgrid Controller and so forth. And initially, we would start off with doing a complete heliscope analysis, which is a program that we use so that based on it has all the meteorological data for the particular site and information on our solar panels. You try to match the two together to see what sort of, depending on the number of quantities of panels we have selected, what sort of solar energy can be produced. Next, John. Another interesting product is the energy storage solution. So this Caterpillar has energy storage solutions, and this is a purely plug and play system. This is designed in North America, manufactured and tested at Caterpillar's factories in Georgia. And these are complete packages with fire detection and suppression system, HV systems, bidirectional inverters, and batteries in 20-foot ISO containers. So these packages are easily transportable. They can be stacked on each other, on top of each other, and they can provide assistance in power in smoothing out, providing quality assurance in power systems, and also storing power and then using them at a later date. So that's called the time shift operation. So these panels, solar, these battery energy storage systems can be used in a variety of different ways. They have lithium-ion batteries, the state-of-art batteries, and safety is paramount in all these packages in the sense that there is fire detection and the monitoring of the gases. There are interlocks in the DC and AC systems and provisions for monitoring door openings and so forth. So that provides a great deal of safety. In addition to that, multiple containers can be added together to provide the rating and capacities dependent on the site requirements, and they are much more easier to install and use as required. John? Perhaps the biggest story of 2021 was the announcement of hydrogen generator sets by Caterpillar. So Caterpillar announced in late last year that it has generator sets that are capable of operating totally on hydrogen, and also announced the fact that the current generator sets that are in the marketplace that have been installed can operate with 5% hydrogen in natural gas. And also Caterpillar is coming out with a kit next year, this year, that will allow for blending between 5 to 25% hydrogen in natural gas. This allows for lower greenhouse gas emissions production from generator sets. So this is a great story for 2021, and these units are now available for use in different locations. Thanks, Sean. So the G3516H is the Caterpillar's flagship hydrogen 100% hydrogen generator set, and it is available in the marketplace. It uses 100% hydrogen and is rated for 1232 kilowatts and available for use. Thanks, John. When we have all these different energy sources in a system, then there is a requirement for a controller. And a typical energy system will consist of electrical loads. It will have the utility as part of it. It will have standby generators. And now we're beginning to see renewable energy sources, including battery storage. And then a microgrid controller is essential in the sense that it monitors the power flow between the different devices. And based on its programming, it is able to provide direction to when different energy sources will be used depending on what the load is. In addition to that, the microgrid controller also provides guidance on any alarms and shutdown, and provides us some information on what maintenance requirements are for particular units. So this device is basically the controller for the microgrid system as a whole. So this slide shows a microgrid system, which is an isolated system. Actually, it's a system that CAT owns, and it is a remote site. It doesn't have a utility, and traditionally it was powered by 3 diesel generator sets. And before CAT got into the microgrid business, it decided to install PV fixed array and PV tracking array systems, and some battery storage and ultra capacitors. And So this system has been in operation for quite some time, and it is typical of a system with different energy sources. And this is where the microgrid controller is providing, monitoring the system, looking at the load, and providing direction for different energy sources to come on and be off. Next slide, John. So this is a snapshot of the monitoring system from the microgrid controller. The yellow graph actually is the site load, and the white line actually is the battery energy storage system, and the blue line is the genset, and the green line is the solar. So initially you can see the battery energy storage system is providing all the load, and then the genset starts running. As the sun rises, the green energy starts increasing, and the load on the generator set starts decreasing up to a point where the generator sets are shut down, and solar is providing all the energy for this particular system and also charging up the battery energy storage system. We can see that there are some spikes in the solar energy, and probably due to cloud effects. And as a result, you can see the white line, which is the battery energy storage system, spiking up to fill in the void of energy at that particular time. So essentially, I've shared the different energy sources that can be put together into a system, the utility, the standby generator sets, or prime power generator sets, renewable energy sources that can work together, and a microgrid controller that can form the basis of a microgrid that can provide resiliency to a system, in fact, and at the same time reduce greenhouse emissions and be much more efficient in providing the energy needs. Thanks, John.
Yes.
Sorry, Megan, you were on mute. I just unmuted you.
Oh, sorry, everybody. Okay, so I was just saying that brings us to the Q&A portion. Thank you, Sharanjit, for that. I don't see any questions coming through on the chat, but we did have some when people registered. So maybe I'll throw this one to you, Sharanjit. When it comes to hydrogen gensets, what is the limiting use?
Excellent question, Megan. So as you know, the gensets are available. They are readily available. And as it is, even the existing gensets can consume up to 5% hydrogen with natural gas. Right now, the limitation is how much hydrogen is in our pipeline. The gas is not available. I mean, if you look at the natural gas that we're getting here today, it's less than 1%. And actually, Enbridge, I think there was an announcement last week that Enbridge is doing a testing in Markham, where there's a certain sector area where they're injecting up to 2% hydrogen and feeling the effects of on equipment. So right now the issue is not the availability of the equipment that generator sets, but it's the availability of hydrogen. Is the first thing. The second thing is how much green hydrogen is available. That's the other part. And right now there is very little green hydrogen available globally. Most of it is gray hydrogen. So that's kind of limiting the use of hydrogen generator sets. And as a result, some of the hydrogen costs are much more higher. And in other jurisdictions in Europe, they are much more higher content of hydrogen in natural gas, and therefore they're beginning to reap the benefits of it in reducing the GHG emissions and using hydrogen in their systems.
Okay, great. I actually have a question for Mary. So, Mary, when we were talking about looking at or the challenge for buyers when they're looking at or trying to understand capabilities of suppliers. Are you experiencing the same thing, that it's just rather difficult to make the determination who's a legitimate supplier, or what actually does this company offer? Is that something that Brock's come across?
Yes, almost by default, institutions, we tend to be very risk averse. So certainly making sure that you identify a good partner, that you know that they are capable of delivering what they are offering to deliver. That's something that's very important for us. It's a challenge sometimes when something sounds so good, to really jump into it, because we're always hesitant. Is it too good to be true? Should we be maybe asking more questions? So we try to do our due diligence. After all, we have to be fiscally responsible. We are publicly funded. So we do want to make those decisions, but at the same time, it can be difficult to balance the innovation with being risk averse at times. So certainly when it comes to new technologies or upcoming technologies, having that assurance that you have the right product, that you have the right partner to undertake those challenges, it makes a huge difference. But it's difficult, and it's not without an effort, that you have to go out and identify them and ask questions until you get comfortable, and then you can proceed with a demonstration project or an initiative.
Okay, great. Thanks for that. I just was curious what your thoughts were, so appreciate it. One of the other questions that we had come through during registration were the pros and cons of using battery energy storage, specifically when it comes to global adjustment applications. So we'll throw that one your way, Sharanjit.
Thanks again, Megan. Yes, battery energy storage systems can be used for peak power mitigation. However, one needs to understand what are the limitations, and also some of the constraints, and also what are the benefits. Obviously, one of the benefits is that it is using electrical energy to charge itself. So, and that's from the utility, and energy is stored, and then the energy is used at a later time. So whatever the source of the emissions is that produces the electricity, that's what the emissions is. In terms of energy storage solution, yes, it can be used for GA mitigation. However, it has limited capacity in the sense whatever capacity of the batteries is available, that's what is available. So if the peak is predicted at a particular time, and the energy is used before that, then the peak is missed. You're not mitigating the peak. And as a result, that may not be effective for a GA mitigation. One of the things we're beginning to hear from the industry is that as there are more and more participants to the peak power mitigation program here in Ontario, it is becoming extremely difficult to predict when the peak is. Generally, the peak is in the afternoon, in the weekday, but we have seen some peaks in the weekends too. And as a result, if there's limited capacity, then it becomes difficult to mitigate the peak using battery energy storage system. So one of the ways of doing that is obviously increasing the capacity of the battery storage system to provide you a much more larger window so that you can start on earlier and use it up to the peak. We've seen a lot this year, especially this year, where peaks were predicted at 6 o'clock in the evening, and then a storm goes through southern Ontario, and actually the peak on that particular day was at 2 o'clock in the afternoon. So that's the sort of window that one is beginning to see as more and more players are coming to the game, and then we have impacts due to weather implications here.
Yeah, of course. I see another question here from Mary from Robert. And Robert just wants to know, how many years have you had the Broadchiller?
We've had it for 3 years. This is our third season. It was installed in 2018.
2018, yeah, with the deep. Okay. All right. So hopefully that answers your question, Robert. So I've got one more question here. So as far as when it comes to energy trends, Sharanjit, what are we seeing in the marketplace?
Very interesting question, actually. There are quite a few trends that are happening in the marketplace. I think the first one is that there is more solar and renewable energy becoming part of our energy mix. And unfortunately, they are not available all the time.
Mm.
So that is that's one of the concerns. The second part is that the cost of energy storage system is beginning to reduce and coming up to a point where it's going to be much more lower than projected. And as a result, a lot more energy storage systems would probably be in place. And that's why it's probably fueled up by the electric vehicles and so forth in the marketplace and energy storage systems. So that's going to be that's another thing that we're beginning to see, and that will help time shift some of the solar and wind energy that can be stored and used at a later date. The other thing that's interesting is that there is more and more natural disasters. As we go back from 1970 to currently, there's more and more natural disasters that are happening. I mean, everybody's kind of familiar about the ice storm we had in Texas last year, the forest fires we had in British Columbia, and then this year, and hurricanes and cyclones that are happening. So there is a demand for systems to be resilient. There's a demand for systems to be flexible, so they can operate with the utility and work independently. And it's exactly pointing to some of the things that Mary highlighted, in the sense that systems need to be resilient and being able to be capable of use in case the utility goes down. And that's where I foresee that the internal combustion engines will still play a huge role in the use of microgrids in the future.
Mm-hmm.
The fourth actually is there is a lot of discussions and talk about meeting 2030 and 2050 emission goals, and that's beginning to have an impact in the marketplace. People are beginning to consider that, and so there's a lot of value statements that are changing, and people are beginning to look at that as well. So there's like four major trends that I see that will have impact for us in the future.
Well, I was just thinking that if we have another serious weather event where we lose power in our area, I'm not that far from Brock University, so I know where to go if I want to get warm, because I know you guys will be powered up and good to go. John asked, Sharanjit, how's the hydrogen supply delivered and stored on site?
So there are companies that can produce hydrogen, and they can cart it on tanks to site. They can come in the form of CNG, similar to that, and then obviously either it can be pre-mixed with natural gas, or they can be mixed at site. So these are large tanks that can be acquired and used. And then there's companies that kind of transport this on a regular basis, bring one tank in and take another way. It's very similar to what's done on natural gas right now.
Okay. And last question, I'm going to throw to Sharanjit. We're talking about specifically, we're talking about GA applications. We were talking about lithium ion battery technology. What are you seeing? Because there's been some rumblings about long duration energy storage. Do you have any predictions as to how far away that is and where the technology is at today?
There has been some talk about some long duration energy storage. I mean, especially lithium-ion batteries, but generally it's been more on the pump storage side of things. Water storage in reservoirs, and using it in the day, and then at night using the excess energy to pump it back into a lake again, and then using it the next day with some vaporization. That's been used in a lot of different places. There's also the cascading effect, where water is used from one dam and then goes into another one and another one. I think Australia is renowned for that. In terms of long duration energy storage, yes, this is beginning. There is some chatter and there's discussion and talk about it. I think this will be probably at a much more higher level in terms of government intervention and utilities and municipalities looking at this, and or even larger customers looking at it and providing that sort of assistance. The trend is that these new technologies that are coming up. It's compacting amount of energy. There's into a small amount of space, and there's zinc batteries that are coming through. There's lithium iron phosphate. So all these technologies will have an impact, but I think it's still very at its infant stages, and it'll be some time before we see that. And I think one of the things that's going to help them is the price of lithium-ion batteries that's going down. That's going to really accelerate this.
Okay, great. Thank you.
Welcome.
All right, so let me just double check. I think those were all the questions in the chat, so we can wrap up unless anyone has any last questions that they want to submit. I'll give you 10 seconds here if you can manage to type that fast. Otherwise, feel free to reach out to any one of us and we can get back to you outside of the webinar. So we'll wrap it up now. That concludes today's webinar. Again, thank you, Mary, so much for joining us. It was a pleasure to have you, and great insights that you provided today. So we really appreciate your time, and thank you again for being here. And of course, Sharanjit, John, our panelists, and especially to everybody joining us on the call today. We appreciate your time and participation. Stay tuned for the next installment of Let's Talk Energy. We will reach out and let you know when that will be. All right, everybody. So have a great afternoon. Thanks very much. We'll see you next time.
Thank
Take
you.
care.
Bye-bye.
Bye.
Bye.